Welcome to Zaption Tour 8.3, Multiplying Binomials. There are 5 boxes. The essential understanding of this short little lesson is that there are several ways in which you can multiply binomials. And I'm going to show you all of the ways, and hopefully one of the ways that I show you makes the most sense to you, and then you can use that from now on. Box number 1 is called the area model. Now I spoke about this one a little bit in the last Zaption Tour, so maybe it's going to look familiar. But consider this product right here. I'm multiplying the binomial 2x plus 1 with the binomial x plus 2. Okay, so remember we're multiplying 2 binomials here. Well, 2x plus 1 can be represented as an x and then the number 1. And then x plus 2 can be represented as an x with a 1 and then a 1. Okay, so what you create out of this is you create a square, or you create a rectangle of sorts, and what you're doing is you are multiplying the length times the width, which is why they call this thing the area model. Okay, so x times x, you multiply on the inside, gives you x squared. X by x gives you x squared. X by 1 gives you x. X by 1 gives you x. X by 1 gives you x. 1 by 1 gives you 1. X by 1 gives you x. X by 1 gives you x, and then 1 by 1 gives you 1. And then all you have to do is add up all the like terms. So I have 1x squared and 2x squared, so I have 2x squareds. Then I have 1, 2, 3, 4, 5 x's, so plus 5x. And then of course I have 1, 2, plus 2. So it must be true that 2x plus 1 times x plus 2 gives me the trinomial 2x squared plus 5x plus 2. Box number 2 is the distributive property, which we've also spoken about, but I'm going to show it to you in a way that you might not have seen before. So I want you to consider this first binomial, 2x plus 4, multiplied by this second binomial, 3x plus 7. And what we're going to do is we're going to pick the first binomial, and I'm going to distribute the 2x to the entire second binomial of 3x plus 7. So it would look something like this. So I'm going to take 2x, this is coming from right here, and I'm going to multiply it by the entire binomial 3x minus 7. Okay, so I took 2x and multiplied it by the entire binomial. Now I'm going to do the exact same thing with the 4, okay? So I'm going to take the 4 and multiply it by the whole thing by that second binomial. So this is going to be plus the number 4 multiplied by a 3x minus 7. Okay, hopefully you see that step. That's a really crucial step. Now we can distribute the 2x again, right? So I can distribute the 2x into the 3x. That would give me a 6x squared. And then 2x minus 7 gives me minus 14x. And then the 4 into the 3x would give me a positive 12x. And then the 4 into distribute to the negative 7 gives me negative 28. And then of course we would combine all the like terms, so I'll bring this problem up here. So I'd have 6x squared, so I have no more of those. Negative 14 and a positive 12 is a difference of negative 2. So negative 2x, and then finally I have a negative 28. So that's a second way that we could use, we could multiply binomials is using the distributive property. Okay, the third method, box number 3, is called the box method, and this is by far my most favorite way to multiply any polynomials, and that's why it's my favorite. But for now, we'll just talk about these 2 binomials. So consider x minus 3 multiplied by 4x minus 5. I like the box method, so I take my first binomial and I take x minus 3. And then I write it down. And then I write down 4x minus 5. So I write down 4x minus 5. So in a way, I'm kind of doing the area model, except I'm not blowing out a 4x's by writing it as x plus x plus x plus x. So it's a little bit quicker. Now all you got to do is multiply on the inside. 4x times x gives me 4x squared. 4x times a negative 3 is a negative 12x. Negative 5 times x is negative 5x. And negative 5 times a negative 3 is a positive 15. Now the really cool thing that I like about the box method is this. If both your binomials are written in standard form, then the diagonals are always going to be like terms. How nice is that? So when I combine my like terms, I get 4x squareds. Negative 5x and negative 12x make a grand total of negative 17x, and then plus 15. So that is by far my most favorite way, also because you're guaranteed to not miss any of the terms as long as all the boxes are filled in. Box number 4 is the good old FOIL. I'm sure some of you have been preview to the word FOIL, which stands for first, outer, inner, last. The reason this is not my most favorite is because LOIF could also work, L-O-I-F, that would also work. Because it doesn't matter which way we multiply things, as long as we get every single term, then we're good to go. But I'm going to teach FOIL because I want you guys to make up your own minds about what you want. So FOIL stands for the first. So I take the first of the two terms and multiply them together. So 3x times x gives me 3x squared. O stands for outer. So I take the outer terms, right? So I take the 3x and the negative 4. So that would be a negative 12x and multiply them together. I stands for the inner. So I take the 1 and the x and multiply them together, and I get a positive x. And L stands for the last. So the 1 and the 4 are the last two terms of each binomial. So 1 times negative 4 gives me negative 4. And then the two terms in the middle are always going to be like terms if you practice the FOIL the way that it's spelled out here. So this gives me, to clean it up, 3x squared minus 11x minus 4. Now again, we could have done LOIF or OIFIL or whatever, it doesn't matter, but as long as you get all of the terms and then bring them into like terms and write it in standard form, you're good to go. Okay, the last box, number 5, is an example of multiplying a binomial, which is this piece here, by a trinomial, which is this piece here. And I'm going to use the box method for the reason that I stated before, because it doesn't matter the size of the box. So I'm going to go ahead and do this in green for you. So I'm going to write down 2x and then a minus 7. Now I could have written it on the top, it doesn't matter where you put it, okay? As long as you just write all the terms down. So what I have here is a 3x squared, I have a plus x, and then I have a minus 5. And I'm going to draw a line for each term. So I have 6 terms that I need to multiply, which makes sense because a binomial has 2 terms and a trinomial has 3 terms, and we're multiplying them together, so we should have 6 terms. So that makes total sense. So here we go, let's fill this in. 3x squared times 2x gives me a 6x to the third. 2x times x is 2x squared. 2x times negative 5 is negative 10x. 3x squared minus 7 is negative 21x squareds. Negative 7 times x is negative 7x. And then lastly, negative 7 times a negative 5 is a positive 35. Now, like I said before, if they're written in standard form, the diagonals will be like terms. And you can see that my squareds are in diagonal and my x's are in diagonal. So then to clean this up, the final answer is going to be 6x to the third. So that one's done. 2x squareds minus 21x squareds is a negative 19x squareds. So that one's done and that one's done. Negative 10x and a negative 7x make a negative 17x. So that one's done and that one's done. And then lastly, I have a positive 35. And that is my final answer when we multiply. So hopefully you can see the box method is very, very systematic and very, very organized, which is probably why I like it. All right, guys. See you later.